So last time I implemented rivers and lakes and forests. It just creates this map, like a random character that moves randomly. So for this I did the game app, the game with the tiles, a unit, battlefield, and then I had the map generator, the basic map generator here. So that was really just a really basic generation. But it's running slow already. There are like very few tiles here. And I want to make this better looking. So the reason that this is running slow is because all of these squares in here are widgets. Which means there's like I don't know how big that battlefield is. What did I set it to? 50 by 50, that's how much is that? 50 and 50, that's 2,500 2,500 widgets, which might not be that much, but it's a small map and it's large fast. So I have to figure out a way to make this more performant. And one way of doing this would be, instead of using widgets like tiles here, I can use chunks. So essentially, instead of using let's say 16 by 16 widgets, 16 and 16, I can use one widget that contains like 16 by 16 pixels or something like that, or maybe more than 16 by 16. So making one chunk. So that's what I want to do today. Let's see, so I'll create a chunk file, and I create a chunk class, which I guess would be a widget. And then I need a chunk size. Chunk size. Yeah, I can't call it size because that will override Kivy. I can't use position either. Oh, let me quickly, because you can't see all of that. Just clean my So here I have an example. So I asked ChatGPT how it would do it. It's not doing it perfectly. So it gives me chunk size to put here, but it also gives me position, which I don't want to set like that because a widget itself has a position, which I think will interfere or might interfere. So I won't do it exactly like that. But otherwise, this is pretty good. So I ask it to create a chunk and then an infinite map. And then to load chunks, I need to add a function to unload chunks, I guess. Although I'm not sure if I even want to unload the chunks because they're not going to be that many. Yeah, I'll just see. Okay, and Kivy arcs and super dot init with KW arcs. And soft texture. Generate. Generate. I was just generating it once. Yeah, okay. Generate texture. By the way, I did this before many times, but I always keep forgetting how to do it. So, but just to ask ChatGPT, and then with self.canvas, with a rectangle, that is texture, self.texture, and pause equals self.pause, and size, self.chunk size. Size is S. So that's the size of the rectangle that we add. And then I need, well, I'll just copy that over. And then I need that function to generate the random texture. Right, so I ask it to create a random texture, but I don't really want a random texture. So that's how I need to use this algorithm here. So at the moment I generate the map, and then I add a widget, which we don't want to do anymore. I also don't want all of this stuff anymore. This has to be removed. It's just testing, really, just simple using your unit movement. For tile, so I already need to chunk it there, really. I don't want to go through it like that, because then it goes like this, right? Like you read a book essentially, but chunks are not like that. Chunks are like, well, a square, bigger square at once. So I don't want the tiles anymore. I don't need that random anymore. So I have the map generated, and then I need to make it into chunks. I guess I could say for chunk in mapgen dot chunks, and therefore I need to modify this. I need to add a property chunks, which returns a I guess a list of chunks, list of list of list of, it doesn't really need to be two-dimensional, it would just be list of tiles, list of tile, and so that would, then I would need to give it like a chunk size as well, and that would be an integer. With height, chunk size, make it 16 for now, and that I want to do a multiple of 16, so maybe 4 times 16. 64, yeah, I think that will work. So 64 here. So the reason I'm using a multiple of 16 is because then it chunks nicely. Alright. I'm not 100% sure to how to implement this yet, but I'm just going and I see how things fall into place. Gives tiles as chunks. So the algorithm for that would be something like chunks, I can make a list, and then I could go for tile in self.tiles values, and then stuff tiles. No, it would be a list. The list would be the chunks, and then the another list would be the tiles per chunk. So it's a list of lists, and then that would be times how many chunks we want, which would be self.width times self.height divided by self.chunk size, I think. And that's complaining because it's a float. I'll just round that. I think that should be fine. If it's a float that doesn't work, then it's probably just because of a rounding error. And I don't want to cut off, like I don't want to make it just an integer because the rounding error might be a bit low. So if it's like 2.999 or something, I don't want it to return 2, I want it to return 3. So we create all the lists that we need, and then we need to get which list to put that in. Which would be the width, self.width. No, not the width. The the tile dot x divided by chunk size. That would be the x position, and then the y position would be tile dot. Well, there's no y position. We just need an I. The y tile dot. I equals that. That is the position in there, and then okay, that's kind of what we get from the x, and then from the y is we get tile dot y times softer chunk size, isn't it? And then I is x plus y. Pretty sure. So x would be for each row, that will give you the x value, and then the y would determine how many rows that is. Like if it's one full row, then it has to add 16 because chunks have 16. Yeah, that makes sense. And then so we can say chunks I dot append tile. Okay, that's how we get the chunks. Not sure if that's the best way, but it's a way. Ideally, well, like since it's not really an infinite map, I can just get the chunks like that because there's no real point in getting a specific chunk at a certain point. So I think that's okay. So we go through the chunks, and then we add the widget, which would be this kind of chunk widget. And that would be could be a class method from tiles. Create chunk from list of tiles. List has to be a list length has to list size to be a multiple of chunk size. Okay, and then we can do that returns chunk. So we want to return class. We need the chunk size. Class chunk size from the tiles it creates a chunk, so it needs to go through from tiles. Well, we're not going to use tiles anymore any longer. It's not going to be widget. There's just going to be a class. But it can still be a what is it called? What widget inherit from? Base event dispatcher, that thing. So tile is a event dispatcher, so that we can define these attributes nicely like that, and also have things like that on row, but they are not useful anymore. We'll see, they probably have to change that as well. Okay, so from tiles. So each tile now is really just a logical unit. It's no longer a thing that is drawn to the screen, which makes it a lot faster. But now we still have to draw them to the texture. So we can say for I need that piece. Well, it's I think this is a texture one way or the other, like that. Which texture is that? Graphics texture. Graphics texture. So create that texture. I know there's like a error message saying that, but that's not actually true. I'm not quite sure why. It still works just the same. Chunk. In your def from tiles line 18. This one, yeah. After KWX you have a chunk. Oh, yeah. This here. That's type annotation in Python. So I don't need to put this here. This is optional. It will work just exactly the same, right? But it's just for us programmers to know what does it return. So this means that it returns, and this is the thing that it returns. And I wrote this in quotation marks because if I remove these, then it doesn't know what chunk is, because chunk is not defined at that point in time. So that's just like a little weird, and yeah, I don't like that, too much quirk of type annotation. But if you put it in a string, it recognizes that. Oh, hey Adam, good to see you here. Okay, so it's creating a texture, empty texture to begin with. And I guess if you really wanted to do it without the from tiles, you could still generate it somehow later on. But if you have tiles, okay, the texture is already generated, so we don't need that. Then I'll just put that here for now. That'll be self.texture. Oh, self. And colors. Have to make colors. I don't want to use NumPy for this one. If I don't have to, let me consult ChatGPT. So I say you used NumPy to create the colors for the texture. How could I do it using the built-in array? There's an array library in Python that works somewhat similar. It's not as advanced, but it's an array. Yeah, I'll show you in a second. So you can use an array, which in other programming languages, arrays, like that's what you call lists, more or less, right? So you are in a different programming language, they call it array, and then you come to Python and there's kind of a list that you're using, but it's not exactly the same. The difference is an array is like a list, but it has a fixed size, right? Whereas a list you can always add and remove things. In an array you cannot. So that makes it a bit more memory efficient, right? If you don't know how long something is and you don't know how to allocate it, but if you have a fixed size, you can allocate it all at once in the memory. ubyte. Let me see if that's the ubyte. RGB colors 2 bytes. Okay, that's still the same. So I just need to create the colors, which is an array. That is of the type B for binary. And then I want to do let's see, tile for tile in tiles, and from the tile I want to get the color, which was tile. I can actually add a property here, color, which returns a tuple of int. That's what it returns. Tuple with 3 integers. So return self.type types and self.type. And now we can use here tile.color, random. Oh yes, okay, so these arrays, the way I would do it right now makes it a 2-dimensional array essentially. But this thing just accepts like 1-dimensional array, right? So it kind of takes all the colors in one line essentially and then breaks it down. It doesn't take like one row of colors, so we have to break that down. So tile a color for tile in tiles, and we say can say color for tile in tiles for color in tile.color, or I guess for V. Yeah. whatever, doesn't matter. So I break, that's how I kind of unpack. So we would have created a two-dimensional list here, and I made it into a one-dimensional list that way. And then I think we don't need any of that anymore. Or is there anything else? No. Alright. So I can remove all of that. Okay, from tiles. Oh, and the KW arcs want to add here. Okay, so now on the battlefield, we create a chunk, the from tiles. I guess you could say the tiles. What else do you want? Tiles. Oh, chunk size. I'll just keep that static for right now. But I'll have to declare that at some point later on. Obviously wrong around. Okay, widgets. It's probably not going to work, but let's see. No, it's not going to work. Object has an attribute X. Chunks. Oh yeah, because that X and Y came from the widget. So we can say X equals numeric property and Y is the same. Can I be integer? Float. Ah, yes, that's another thing. So I stored the values between 0 and 1, right? So that's the color range from 0 to 1. But Kivy wants a color range for textures from 0 to 255. So to fix that, I could just say v times 255, and then I round that, I guess. And here we go. Okay, you see, it did draw it, but it's just very small. If I make that bigger. So it did draw it, it's just very small. So I have to fix that. And to fix that, we can make a chunk a lot bigger. I'll just, for now, I just put that here, but I probably change that sometime. I want the size to be each chunk, let's say 16 by 16, just for now to see. And I also want a chunk not to be of relative size, so we can say size hint equals none. Still very small. What am I missing? Okay, now what am I missing? So it's I missed doing the X and Y, so it's drawing it all of the chunks in the bottom left corner. but that should be considered from let me size 16. So change that here, so I don't have to put that here anymore, so it's universal. And then x and y, or what is it called? Yeah, x equals self dot size 0 size times, I moved it up, x equals self dot size 0 times, or actually, since this is a widget, I can use self dot width times times chunk size. Right, so this is not actually going here, because in this case we don't actually know where to put it, but here we do. X y equals y, self dot height times tiles. So the first element in the tiles, the y, right? So the first is like the bottom left corner. So from that tile we want to take the y to set the chunk size. But I don't have self yet. I guess it could just be size equals 16, and that would be size. And then this would be s dot size, because this shouldn't change ever. Like every chunk in the game should be the same size anyway, so this should not really change. So I could just say the tiles 0.x, and that should be x and y, and that still doesn't do it. Okay, what's going on here? All of them are 0. Okay, that explains why they're all still drawn, but why is it 0? Because self-less size should not be 0. So tiles x and y, that's not set, I think. Tiles in map row x and y. So that should set it. Oh, tile. Right. Okay, I see. I made a mistake there. So I called it initially row and column because I want it to be different from the widget row and column, but now I don't have that anymore. Row, column, row. Okay, I'm not using that anymore. Okay, at least an error now. Destinate out of range. I really wish Python would be a bit more descriptive sometimes. Like, It would tell me what I is in that case. Print I, let's see. $256, and yeah, that's 250. Chunks. It's 256, right? Where is my mistake here? So I'm going. Yeah, I think I'm doing the wrong way around. So when I go through the x's, I want to convert that to the chunk. I think that's correct. But then the y is the mistake. The y is not chunk size, but rather it is divided by chunk size times chunk size? No, hang on. Divided by chunk size will give like the y of the chunk. And that would be times chunk size. But that's the same thing, right? Y. Divided by chunk size. But that's the same as just removing all of this, isn't it? I'm doing this calculation. I've done this calculation so many times, but every time I do it, it's confusing me. So the y of the tile has to be floor divided by chunk size, so you get the chunk y, and then you want to multiply that. Okay, yeah, no, that's not the same because this is a floor division, so that should be still 0. Okay, there's no longer this error, but it's still 0 for some reason. Where does this other print? From tiles. Because that doesn't make any sense. 1 second. So the very tile.y is the tile y it's 0. And for the first one, it makes sense, right? The bottom left tile that is should actually be 0, and so the bottom left chunk should also be 0. So that makes sense. But then the rest should be something else. What am I making wrong here? Because you see, these are all generating from 0 and then 1 and then 2 and then 3 and so on. So they're generating correctly. Where's my mistake? Tiles map chunks, probably in the chunks here. Tiles dot tile 0 or tile dot x tile dot y for tile in tiles. Let's see what that does. Oh yeah, it's a generate expression. Just print out anything. 0. Okay, so there we go. So it doesn't give us the right chunks here. It gives us everything. 1, 2, 3, 4, 5, 6, 7. Print. Oh, that would be just the tiles. So something's wrong with this method here. So let me just step through that. Okay, so that has 256 empty lists. That is correct. Then we create a tile, or we get a tile, and that has x and y of 0. That's correct. That's 0 and 0. That's correct. And then y 0. That's correct. Okay, so that's get added. It's added to the first one. Then we get a tile with x1 and oh, I see. Because the tiles are generated the wrong way around, essentially. Well, it doesn't really matter, but for my calculation, it does matter. Or does it actually? No, I don't think it actually does matter. I think it doesn't really matter. Okay, so that's correct, and then for 2 it's correct, and 3 it's correct, and 4 it's correct, and so on. Until we get to 16. 8, 9, 10, 11, 12, 13, 15, 16. Okay, 16. Okay. 16. No, that's correct as well, right? Because like there's 16 chunks, and then one down, that's the 16th chunk. That's correct as well. So why does it... Oh, okay, yeah. I see what's going on. Okay, I look very stupid now. So because I'm doing this times, I normally don't do this. I've shown that recently in a class that I did, that you can do something like that. And I didn't, so I knew that if you do something like a equals list or something, and you keep reusing this list, like you keep calling this list gets filled. So you shouldn't really do a list as default argument. But apparently this also applies to this kind of thing. So all of these are the same. So equals times 3, and then if I say ID of I for I in A, see they're all the same ID. They're all at the same. They're all the same list. They're all the same list. The same reference. Okay, apparently that doesn't work. Something new learned every day. For I in range. This looks a bit ugly. Num chunks. Num chunks. That looks better now. I've also create colors underscore since I don't even use this. Alright. Is next out of range. Didn't get any tiles. Print tiles. So we get a couple ones here. And then it fills after the fourth one. After the fourth one, it's empty. Okay. That seems suspicious. There's probably some calculation error in here, and it's probably adding more to some lists than it does to others. Yeah, well, I'll have to solve that next time. Alright, well, I have to leave early today, but next week, Friday, I will go over, well, I'll look for a solution in the meantime, and then I will present that solution. And then we will get on with the texturing. And we're very close to showing this actually off, how it works. So we'll get to that next week. Alright, thank you everybody for your attention, and we talk then. Bye.